also am Irish, so I have a tendency to speak very quickly, so tell me to slow down if that happens. Okay, so it's a 4-year project, started in 2013, so we're about 2 years into the project. So at the moment we're very deeply involved in a lot of the scientific work. So what I'm going to do today is to give you an overview of what we're doing within the project, but I'm not going to present results in any great detail, okay? So just to introduce myself, as Andrea said, I'm Niamh Connel. I'm based at the Institute for Global Food Security in Queen's University in Belfast, and we have quite a lot of experience in managing framework projects over the years. I am not an animal nutritionist, I'm not a geneticist, I'm not a microbiologist, I'm an animal welfare scientist, and that's why I put the picture up. I don't know if I have a pointer here. Is there a pointer? No? Okay. I put the picture up anyway of the chickens and the sort of work that I do in relation to enrichment for commercial broiler chickens. So my role is largely administrative within this project, trying to make sure that everybody is meeting their deliverables, managing the finances. I work very closely with the Deputy Coordinator, which is Elizabeth McGowan, and she's based in the Agri-Food and Biosciences Institute in Hillsborough, just down the road. And she has really driven the science of this project from the very start. So I just want to give a quick bit of background as to why we're doing this particular project before I talk about the detail. So as you're all aware, intensive agriculture, really characterised by large-scale specialist production systems with a lot of emphasis on production performance and efficiency, has evolved in the last 50 to 60 years as a method of meeting increased demand for food associated with global population growth, increased urbanisation. This demand is predicted to increase. As we're all aware, global populations are rising, expected to reach almost 10 billion by 2050. And at that stage, about 67% of the global population are likely to live in urban areas. So we're going to have more people in the world, they're going to be eating more food, and this is linked to economic growth. Per capita income is likely to increase 1.8-fold between now and 2050. And along with this increased economic growth, we see a shift in dietary patterns away from vegetable-based food and more towards livestock-based food. So we're going to have more people wanting to eat more livestock products, and this is contributing to this predicted increase in demand for meat. Which you can see here, the increase is declining as we go over the decades, but there still is an increase in predicted demand. And it is anticipated that we'll have to increase meat production by, gosh, I think it's about 155 million tonnes, I could be wrong there, by 2050 to reach a target of 450 million tonnes of meat production globally by 2050. So we're going to have to produce more meat if we want to meet this increased demand within the constraints of competition for resources from other enterprises, for example, competition for land, for biofuel production, competition for water, and also within the constraints imposed by increased concerns about environmental impact of agriculture. Increasingly, people are worried about the effect of nitrogen and phosphorus, contamination of our soils and our waterways, about greenhouse gas emissions and effect on climate change. So this is the dilemma that we face in livestock production. We need to feed more people, but in a more efficient way. So really a key goal, and this is why we keep hearing the term sustainable intensification constantly at the moment, and a key goal within this concept must be to increase efficiency and reduce ecological footprint in key monogastric meat-producing animals, and specifically with pigs and broiler chickens as the major contributors to meat production globally. So we need to make these animals more efficient in how they use resources and how they produce meat. Every grain that they eat has to be used with maximum efficiency and with minimum environmental impact. And while we're also trying to strive to achieve this, we have to ensure that we don't compromise food safety, meat quality, animal welfare. So we have a tall order. So that's really led to the objectives behind the ECO-FCE project. And really the project is about trying to understand interactions within the system that create differences in feed efficiency, that lead to better feed efficiency in some animals than others, and also lead to differences in excretion rates between animals. So the first part of the project is really about understanding what's happening within the animal, and the second part is about using this improved understanding to develop tools for the industry. I mean, obviously we want to leave a legacy with this project, and we really hope to particularly help the nutrition and the genetics companies. So our partners we have 17 partners on the project. Over a third of them are industrial partners. 5 out of 6 of these are SMEs, and the other is COB, which represents about 45% of broiler production globally. And the other companies, many of them are related to animal nutrition, others to animal genetics, and of course RTD Services is one of our partners involved in dissemination of this project. So we hope with such a large contingent of industry support that the project has been well directed from the start in terms of ensuring maximum impact, and that this impact should happen quite quickly at the end of the project. And of course we have a range of academic partners as well, which you can see on the left-hand side there, with specialisms in things like animal welfare, in microbiology, in animal production, in meat quality, in gut structure and function. I'm not going to go into the details of our management structure, but just to say that it's modelled on previous projects that we've managed through Queen's. It's quite stratified and is working quite well, and we have very good risk management tools in place to ensure that we meet our deliverables as we need to. So the project itself has 7 work packages, 5 scientific work packages in grey there. I'm going to talk about them in a little bit more detail in a moment, but the first work package is really an information gathering exercise, trying to capitalise on the literature that's out there at the moment in relation to feed efficiency in pigs and poultry in particular, and to add value to this information through some meta-analysis, which I'll talk about in a moment. This work package was also used to standardise the methodology, which we're using in the main experimental work packages, which are work packages 2, 3 and 4. And these essentially involve experimental work trying to investigate the effect of feed, gut and microbial factors and genetic factors on feed use efficiency in broiler chickens and in pigs. And then these packages all fit into work package 5. They all feed into this work package, which is about developing tools for industry, as I said, to leave a legacy for the project. And then work package 6 is dissemination, and work package 7 is project management. So just to talk about the work packages in a little bit more detail, as I said, work package 1 is about making most of the use of the literature that already exists on feed use efficiency and also nutrient excretion in monogastric species. There are thousands of papers that have been published in this area, literally thousands. But nobody has ever tried to put this information together and to make more use of it. And what we're particularly interested in is trying to assess the relative impact of feed-related factors versus genetic factors versus gut-related factors, the relative magnitude of the impact of these factors on feed use efficiency and nutrient utilization. So we have set about gathering in a very structured way all of the literature that's relevant, and I'll explain in a moment just the methodology to that, and generating a very large electronic warehouse of information, which will then be, key data will be extracted from this for meta-analysis. And this meta-analysis will ultimately form the base of a web-based tool that will be one of the outcomes of this project, where people will be able to enter queries relating to issues they're interested in, and should be able to receive an answer in a sort of a hierarchical search term, a web-based tool. This practice also lends itself to horizon scanning and identifying knowledge gaps, and that's ongoing at the moment. And this work package, as I said, was also used to standardise methodology for things like animal welfare assessment. We have projects and bits of research happening all over Europe in different centres. We need to have standardised protocols for taking meat quality samples, for taking animal welfare assessments, and all those protocols were decided within work package 1. So I'm not going to go into too much detail here in relation to the literature review. This was a structured literature review on feed efficiency. It involved almost all of the partners, and the picture I had on the previous slide was to represent the distress that this process caused for the work package leader, which was Elizabeth McGowan, because once she had gathered all of these papers together that were relevant for feed efficiency in monogastric meat-producing animals, she then had to send out, and there were over almost 1 million of these papers, she then had to sub-select about 1,200 of these papers and send them out to our partners to extract key information from these 1,200 papers in a very structured way. And this was a very difficult process to manage, but she succeeded, and we now have a really good database of information that lends itself very well to meta-analyses. And I think while we will obviously use this and do a lot of analysis with this data, I think it could be a really useful resource for other scientists in this area. Nobody before has got all of this information together before. So we have a spreadsheet of information on chickens, and this all relates to feed efficiency and all of the different treatment factors that might potentially affect feed efficiency relating to feed, gut, and genetics. And this particular spreadsheet has 8,000 lines of data. It's an enormous resource. And the spreadsheet for pigs has almost the same number of lines of data. So they're big tools that can be used for many different types of analysis. So those data sheets are now gathered, and we're starting, that's just an example of the spreadsheet that was sent out to partners to gather the data from the papers. But Elizabeth is starting to look at what the papers look like, what we could potentially explore within these big data sets gathered over the last, and as I said, we just picked the last 5 years of publications, and we just picked pigs and broiler chickens from all of the monogastric species that we gathered papers for. So you can see here that some feed ingredients on the left aren't really used that often in research. There's not a huge amount of information, but other feed ingredients are used much more frequently in experimental treatments. So they lend themselves very well to further analysis. For example, comparing the effects of corn and wheat and barley on feed efficiency in a structured way. The same with things like additives and enzymes. You can see the number of times different additives and enzymes have been used in experimental treatments within our database of information. Again, it lends itself very well to further analysis to try to tease out the relative importance of different additives or enzymes. And some of the key questions that Elizabeth will be working with the statisticians on and trying to tease out would be, firstly, the big question that we wanted to answer from this exercise. What has the biggest effect in terms of magnitude on feed efficiency in pigs and poultry? Is it feed-related factors? Is it genetics? Is it gut-related factors? And potentially we may also be able to look at interactions